I have three polygons drawn on the board, and I'm making one assumption, that is these polygons, they are regular polygons, because in irregular polygons we don't know what shape, what angle, what line length it will be, and it will be difficult to analyze. So for these polygons, let us find out that if there's a point inside the polygon in each case, and I'm going to draw a line horizontally from this point which tends towards infinity. Then this line intersects the polygon exactly one number of times. It intersects the polygon exactly 1, 2 and 3 number of times, and it intersects the polygon exactly one number of times. So we are making an assumption that if there is a point which lies inside a regular polygon, then it intersects the line intersects the polygon odd number of times, and this is going to be the bread and butter of our problem, because we are going to simply rely on this. So let us proceed, and for our convenience we are taking this hexagon for all test cases, for all problem solving things, and this is going to be a pretty tricky and a long program, but we'll find a way out. We got to understand that any such problem that involves computational geometry involves all these four planes. That is, we have the x-axis, we have the y-axis, we have the positive side, we have the negative side, and we have to work accordingly so that our problem can be solved for any such quadrant in this plane. So for this problem I am making use of what we study in data structure and make a data type point. Now point is going to have two coordinates x and y, right? And we'll take a polygon array, and this polygon will have a number of points. Since the polygon has a number of points, so we'll make a polygon array which has, let us say, n elements, and these n elements are actually endpoints which have each one of them have their own coordinates x and y. So let us proceed with the problem. Now how do I approach this? Now my approach to the problem will happen in 4 different steps, and the first step I am going to say on segment. This is actually a function. All these steps are functions. And the second step, let us say orientation. The third one, I'm going to name it do intersect, and the fourth one is inside. So we are going to move from on segment to orientation to do intersect to is inside functions step by step, and in each function we are going to call the previous function, right? And let me declare the return type of these functions. So return type of this can be boolean. What are we going to do here? We are going to return true if our, let us say there are two limits, and these limits I'm going to call them P and R, and there is the point Q in between of them. So if Q lies between P and R, that is, it is on this segment where we have to solve for our polygon, I'm going to say that Q lies on segment, and the return type will be boolean. It will return true if this case is satisfied, otherwise it is going to result false. And for orientation, the return type will be int, because we are going to use a formula where we'll find out whether the point Q, let us say, it lies on the edge of polygon or not, because for our case in which we have to find out whether the point lies inside the polygon, if the point lies on the edge of polygon, it can satisfy our case pretty much, because if we draw a line from here, it is intersecting it exactly one time, and for other large polygons it will intersect odd number of times. Now do intersect will also have a return type of boolean, and it will return true if our point intersects with the point of polygon, that is the line drawn from the point intersects, if it intersects with another point of polygon, it is going to return true, otherwise false. And is inside, also we'll have the return type boolean, and it is going to return true whenever we have this point inside the polygon, and false if it is outside or on the edge. So how are these two functions different? It is going to return true if we have the point on the edge, and it is going to return true if the point is exactly inside the polygon. So let us proceed with our first function on segment. Now for on segment function, I am going to take three variables, p, q and r. Let me erase it first. So let me declare this. Now we can use any language, but I am preferring Java over here because I'll make use of certain functions like maths.max and so on, but it's up to you. Whatever you take, you can use Python, you can use C and all such other programming languages. So let us say that I'm using public static, this is the return type boolean, and the name of our function on segment. And I'm going to take three variables, each with data type point. So point P, point Q and point R, because we have to find out that this middle point Q, it has to lie within these 2 points. So how do we find out? I'm going to take a simple conditional statement if q dot x, that means x coordinate of point Q, if it is less than math dot max px comma rx and q dot x is greater than math dot max math dot min. It has to be greater than the minimum of these two and greater than the it has to be less than the maximum of these two and greater than the minimum of these two. And same for the y coordinate. Sorry, I just wrote over here max, it has to be min, it has to be max, and here will be min because it has to be greater than the minimum and less than the maximum. So as simple as that, we are going to take three variables with data type point, and we have to find out for each coordinate if the coordinates of x and y lie between the minimum and maximum of these p and r, which are the two extremes. We are going to return true, which means our point Q is on the segment and we have a possibility that the point lies inside the polygon or not. Now let us proceed towards the next function, that is the orientation function. So for orientation, we had our data type int, return type int. So I'm going to take int, and let us take these 3 points, point P, point Q and point R. Right, now in orientation we have to find out if the point lies on the edge or if it is lying inside. So first of all, I'm going to calculate the condition in which the point is on the edge of polygon, that is, it lies on the polygon. For example, if this is a polygon, the point can lie anywhere over here, here, and there's a formula for this which we are storing in the int value variable. So now int value will store, this is actually a formula to find out if a polygon lies on if a point lies on the polygon or not. So first of all, we are going to test the condition by storing this value over here, and if value is equal to 0, we are going to return 0. And let us say, if let us put a test condition that if value is greater than 0, let us return 1, and if it is less than 0, let us return 2. So we are basically concerned with this because if our point lies on the polygon, we'll get to know by returning 0. Lies on the polygon by using the orientation, that is, we are finding the orientation on the point. And if value is greater than 0 and less than 0, they also give the orientation as to if the point is inside the polygon or it is outside the polygon, on the left side or on the right side. Now let us proceed that whether the line drawn from the point intersects with a point on polygon or not. So I'm going to erase this. Now this function is going to be pretty lengthy, our do intersect function, and I'm going to tell you why. Because we are going to calculate all such possibilities in which the line drawn from the point intersects the polygon or not. So I'm again using public static. The return type was supposed to be boolean, and we have do intersect. So I'm taking 4 points as parameters over here. So let us take point P1, point P2, point Q1 and point Q2, because here we are going to take all such possible conditions in which the line drawn from the polygon intersects the point on another polygon or not. We are going to find out. So we are taking every possible case in which this happens. So first of all, we are going to calculate the orientation of 4 points. Let us say we have 4 integers, int o1, o2, o3 and o4. First of all, we are going to find the orientation of all these points so that we know whether these points lie on the polygon or not. So let us say these integers are going to store the orientations of these 4 points in different combinations. So I'm going to write o1, o2, o3 and o4, and all of them are calling orientation function. And this is going to be Q2. So we have used 4 possible combinations in which we are going to calculate the orientation, and I've taken care that we take Q1 in the middle and Q2 in the middle, and here we have P2 and Q2 alternatively, and we are starting from P1 and P2. So in these 4 possible combinations, we are going to find out the orientation, and it is going to return a value 0, 1 or 2. So what are the possible cases? We are going to return true if the line drawn from the point will intersect the polygon. So first of all, we have seen that if we have q1 in between these 2 points, p1 and p2 and p1 and q2, that means that if both of them are equal, obviously our point is not going to intersect. Why? Because here I'm using 2 different points, here I'm using 2 different points, and if they happen to be same, then obviously we are not having a polygon. So our first case, and similarly for these two, O3 and O4, so first case is very simple, that if O1 is not equal to O2 and O3 is not equal to O4, we are going to return true, that we will have a point emerging from the we are going to have a line emerging from a point that is going to intersect a point on the polygon, right? So this is our first case, and if both of them are equal, that is not going to happen because we will not have 3 different points in that case. So now let us begin to other cases. Now let us say we're dealing individually. If O1 is equal to 0, and let us call the segment function over here, like we know that it is lying on the polygon, and now we have to check whether this point lies within the limits of the extreme points on the polygon. So we're going to call it in such a way that we have p1, p2 and q1. Then we are going to return true. Similarly, if O2 is equal to 0 and on segment P1, Q2, Q1, so again I'm going to return true. If O3 is equal to 0 and again I'm calling on segment for P2, P1 and Q2. And since we are running out of space, I'm going to just erase this part of the program. If O4 is equal to 0 and on segment P2, Q1 and Q2, so again we are going to return true. Now one thing to notice is this combination and this combination. Now why are we using this? Because we have calculated the orientation and it comes out to be 0. That means that the point lies on the polygon, right? And now we are changing the order, that we are taking P2 in the middle and Q1 over here. Why? Because now that we know that the point lies on the polygon, we are going to set different limits to cross check whether our point lies on the polygon or not. Now let us proceed towards the last function of our program, and we need to use all the strategies that we have used before, like previously, to solve this function. So I'm going to write first of all. Now here I'm going to stick to Java a bit because I find it easier in this case, but it's not mandatory for you. Now we'll take a polygon array as discussed with data type point, and another point P, where we have to find out whether P lies inside this polygon or not, and an intent, which is the limit of polygon. The very first step is very easy, that we have to find out that if n is less than 3, we are going to return false, because polygon always has 3 or more points, right? So first of all, I'm going to explain you the workflow, what I'm going to use. Now in this function, I'm going to call all these previous functions. Like we are going to call the doIntersect function. So first of all, if I find out that the line drawn from my point P, if it intersects a point on the polygon, if this case is true, then I'm going to find out the orientation, right? And if the orientation is equal to 0, then I'm going to find out the on segment, right? And if this is also true, then I'm going to, let us say, increase take a counting parameter and increment the count, right? Now then I'm going to find out that if this count is odd number, then only I can say that my point lies inside the polygon or not. So this doIntersect function will require 4 variables, 4 parameters. Orientation will require 3 and on segment will require 3, and these two, as solved previously, they require the same. So let us say that for on segment, and I'm going to draw a polygon over here, if we have, let us say, this I point, and let us say there's this next point, that is the next point of the polygon, so the next point will obviously come over here, and I'm going to take P somewhere here, right? So this is my strategy of solving these two functions, right? And why I'm taking I and I next is why what I'll do in intersect function, I'm going to take one extreme point, right, which has the maximum value, let us say a very arbitrary large number like 10,000 or something, and this point extreme will also be used in finding out the return value of this doIntersect function. So this is going to work in this particular order, and the loop which I'm going to use is do while loop. Why? Because even if one case is false, we can execute it once, right? We can run it once. So let us proceed with this particular strategy. I'm going to take INF. INF is used in Java. It sets the maximum value of an integer used in this function, and let us say I am going to set it to a very high number, 10,000. And let us take an extreme point for our doIntersect function. So point extreme, which gives us a new point, and it takes the x coordinate as this and the y coordinate as p dot y, right? And this is going to be used for our doIntersect function. So my first step is a test condition, that if doIntersect, and I'm going to use, no, first of all we have to start a loop, and this is do while loop, and let us say that my next point is going to be I plus 1 modulo n, so that I get one point I and next point after I of the polygon. So now I'm proceeding like, if doIntersect, and take these 4 points, like point polygon I, that is ith point of polygon's next point, next P, and extreme. So if this returns true, I'm going to step back to orientation, and for orientation we do not require extreme, so we only require the ith point of polygon, P point, and the next point. And if it is equal to 0, we are going to return the on segment of these 3 exact points, right? So I'm going to return and polygon next. I'm erasing this entire thing because we are running out of space. Okay, so after returning the value, we have, let us say, an int count which is equal to 0. Obviously we have to declare it outside, so count will increase, and we are going to close this do while loop, and this I will become next. So what is my strategy I used over here? Let us say that this is a polygon which has A, B, C, D, E, F, right, 6 points. So first of all, I'm going to compare for these two values, then I will become next. So this becomes the next value, this becomes I. So we will continue till here unless I is not equal to 0. So you got my point, I hope. And